Hello everyone, myself Professor Amol Mishra from Department of Electrical Engineering from SND College of Engineering and Research Center, Yavla. Today we are going to discuss on the topic differential relays. So first we are seeing that the definition of differential relay. So what is a differential relay? A two-winding relay that operates when the difference between the currents in the two windings reaches a predetermined value is called as differential relay. A two-winding relay that operates when the difference between the currents in the two windings reaches a predetermined value. In case of electrical quantities exceed a predetermined value, a current differential relay is one that compares the current entering a section of the system with current leaving the section. Under normal operating conditions, the two currents are equal, but as soon as fault occurs, this condition is no longer applicable. The difference between the incoming and outgoing current is arranged to flow through relay operating coil. If this difference is equal to or greater than the pickup value, the relay will operate and open the circuit breaker and isolate the faulty section. Any type of relay, when connected in a particular way, can be made to operate as a differential relay. It is not the relay construction, but the way in which relay is connected in a circuit makes it a differential relay. There are three fundamental systems of differential or balanced protection. First one is a current differential relay. One is a voltage differential relay, and third one is a bias beam relay or percentage differential relay. Then we are seeing the first one, current balance protection. In figure shows an arrangement of an overcurrent relay connected to operate as a differential relay. A pair of identical current transformer is fitted on either end of end of the section to be protected. Alternator winding in this case. The secondaries of cities are connected in series in such a way that they carry the induced currents in the same direction. The operating coil of overcurrent relay is connected across the city secondary circuit. This differential relay compares the current at the two ends of the alternator winding. Under normal operating conditions, suppose the alternator winding carries a normal current of 1000 ampere, then the current in the two secondaries of city are equal as in figure. These currents will merely circulate between the two cities and no current will flow through the differential relay as shown in the diagram. Therefore, the relay remains inoperative. If a ground fault occurs on the alternator winding, the two secondary currents will not be equal and the current flows through the operational coil of the relay, causing the relay to operate. The amount of current flow through the relay will depend upon the way the fault is being fed, as shown in figure. The disadvantages of differential relay. The impedance of the pilot cables generally causes a slight difference between the currents at the two ends of the section to be protected. Then the small differential current flowing through the relay may cause it to operate even under a no fault condition. Pilot cable capacitance causes incorrect operation of the relay when a large current flows. The third disadvantage of differential relays: accurate matching of current transformers cannot be achieved due to pilot circuit impedance. The second one, we are seeing the voltage differential relay. The figure shows the arrangement of voltage balance protection. In this scheme of protection, two similar current transformers are connected at either end of the element to be protected. Example, an alternator winding by means of pilot of wire. The secondaries of current transformers are connected in series with a relay in such a way that under normal conditions, their induced EMF means the electromotive forces, are in opposition. Under healthy conditions, equal currents will flow both primary winding. Therefore, the secondary voltages of the two transformers are balanced against each other, and no current will flow through the relay operating coil. When a fault occurs in the protected zone, the currents in the two primaries will differ from one another, and their secondary voltage will no longer be in balance. This voltage difference will cause a current to flow through the operating coil of the relay, which closes the trip circuit. The disadvantages of voltage differential relay. The voltage balance system suffers from the following drawbacks. A multi-amp transformer construction is required to achieve the accurate balance between current and transformer pairs. The system is suitable for protection of cables of relatively short length due to capacitance of pilot wires. Third one, we are seeing the bias beam relay or percentage differential relay. The bias beam relay, also called percentage differential relay, is designed to respond to the differential current in terms of its fractional relation to the current flowing through the protected section. It's called percentage differential relay because the ratio of differential operating current to average restraining current is a fixed percentage. It's called bias relay because restraining known as bias coil produces as the bias force. The figure shows the schematic arrangements of bias beam relay. It is essentially an overcurrent balance beam type relay with an additional restraining coil. The restraining coil produces a bias force in the opposite direction to the operating force. Under normal through load condition, the bias force due to restraining coil is greater than operating force. Therefore, the relay remains inoperative, as shown in figure. When an internal fault occurs, the operating force exceeds the bias force. Consequently, the trip contacts are closed to open the circuit breaker. The bias force can be adjusted by varying the number of turns on the restraining coil. Thank you.